example of an application for evaluating an activated sludge process and its settability. And we call this diagnostics because you're going to be looking at both the activated sludge process and the settling characteristics due to the results of a specific oxygen uptake rate. You'll see here that you have the input parameters are the raw sewage flow, the suspended solids, the applied COD or BOD. Usually it's easier to run the COD, and then over time you'll develop a ratio of COD to BOD. And in this particular case we know what that ratio was, so we now can estimate what the applied BOD would be. The effluent suspended solids, I've just added these values. I've put 25 for both, and the volatility of the suspended solids is 75% for the material coming in. Lab data, you want to run your mixed liquor. In this case it's 2790, and the return sludge is 7360. We're using an aeration basin size of 360,000 gallons. We use a default coefficient of 0.5 pounds of solids growth due to the BOD. You can determine that for the specific plant you're involved with. And then you have the wasting, which for this instance we're just using the 21,000 gallons a day. Let's look at the output parameters. We've calculated out the mixed liquor volatile suspended solids, the return volatile suspended solids, and due to the wasting and loss of solids we come up with a sludge age of 4.38 days. This is your net effluent flow, and then we do mass loadings and we do projected growth. We do, based on the ratio of mixed liquor suspended solids to return activated sludge suspended solids, we come up with 61%, which is then translated into 1.4 million gallons. Here is where you enter your 30-minute settling test. In this case I've put in 700 milliliters, and then it calculates out the SVI. You might wonder why we have BOD applied twice. Well, you might want to have a separate BOD value for the test for the specific oxygen uptake rate. And for that test we have the ambient wastewater temperature, in this case 11 degrees. You measure the DO at the start, and 4 minutes later it was 0.6. You'll see that the value for 20 degrees C is 26.4 milligrams of oxygen per hour per gram, and you'll see at this temperature it's 13.4. It predicts out what you should expect, the range for the 30-minute settle sludge volume, and then it gives you an indication of the type of sludge that you have. In this particular case, if I'll change this and make this 6 minutes, and I'll solve it, and it's still normal, but if I go out here to 10 minutes and solve it, you'll see it's fast settling, endogenous respiration, and what type of organisms you might see. This is a good approximation of what you should see under the microscope. Demonstrates some invertibility. Right now we have 25 here and 25 here, and the sludge age is 4.38. Let's make both of these 10 and this 10, and you'll see that the sludge age is 5.47. Now if I were to clear this, which is the amount that we're wasting, and I say okay, I want a sludge age of 6 days under these conditions, how much sludge should I waste? 18.785 gallons. This is what invertibility does for you. Okay, I can leave this the way it is, and you can also do this with the settled sludge volume and the SVI. If I was wondering what the settled sludge volume should be for an SVI of 200 and I solve it, you'll see that it should be 558 milliliters. This is what invertibility does for you. It allows you to come in and do these what ifs for scenarios before you actually make a full plan adjustment. So you could increase your flow, decrease your flow, you could adjust your mixed liquor suspended solids, and all these variables are interactive and invertible. What's not invertible is the specific oxygen uptake rate, because we're putting these input values in and it's giving this. So for a diagnostic tool for evaluating your activated sludge process, this coupled with our stake point analysis will give you a good idea of where you stand on your biological process, on your oxygen uptake, and on your clarifier performance.